Roger Webb, and today on this 16th episode of building the MAXI CNC Router, where all the information regarding the parts and very soon to have all the drawings on my Patron pages if you are interested. So today we are going to wire up all the stepper motors, drivers, and set the drivers up with the dip switches, which is what we're going to start with actually, and wiring up the Mach3 board. And I think I'm going to devote the next video to setting up Mach3 because that's quite complex, and it would entail sort of a good 20 to 30 minute video just to do that properly. So let's make a start with the drivers. This group of numbers here, this is all related to the dip switches, because this little stepper motor driver can supply varying ampage and varying pulses per ref. So it is quite simple really. Now we have NEMA 24s that are 4 Newton meters of high powered torque. So we will want this on the highest ampage output setting. Okay. There are 2 settings here. One is RMS. This is normal running ampage, and this is peak ampage. So this is the one that we would switch on. So we would need to put the dip switches, which are here, dip switch SW1, 2 and 3, in the off, off and off position. So we'll do that right now. So one is off, off and off. Okay, so that's the first 3 done. That's the ampage sorted out. Okay, so the next one to come to is this one here, SW4. In the off position you get half current, which is half of these figures here that you've just set, and in the on position you get the full current. So for our purposes, being a brand new machine, so we're going to run this at half current, and then when we're sure everything is correct, then we'll switch it to full current. So we'll just check to see what we've got. Switch number 4 is in the off position, so that's correct. Now the next group here, this regards steps per revolution. Now I normally start off with 400 steps. The speed is fine, and I can alter in Mach3 for the accuracy. In other words, I can tune it in using the program, and I've never had a problem, so I always switch the unit to 400 pulses per revolution. So it's off, on, on, on. So let's do that. So it's off, oh. They can be a bit stiff. Probably best to use a flat bladed little, there we go, on. Let's just check that. So it's off, on. just to check. Off, on. Yep. Okay, so that is now correct, and the dip switches are set for the startup of our machine and to get it running. And when we know everything is running correctly, we can alter switch number 4, dip switch number 4, to the on position to give full current. In this build, I have used NEMA 24 high power output stepper motors. This is a NEMA 24, but it's slightly smaller to the ones I have fitted to the MAXI CNC router. Now, then a lot of people ask me, how do you know which wire to connect to the driver? And how do you know which wires are connected to which coil? Well, I'm going to show you how to determine that. Well, if you buy from Stepperonline, they will provide you with a full spreadsheet that indicate to you what colors and how to connect them into the driver, being A minus, B minus. If you don't have a spreadsheet like this, now many sellers on eBay and Alibaba and what have you will just send you a stepper motor with no paperwork whatsoever. So a quick way to determine which wires are connected up to a particular coil inside the motor. With all the wires free like this, you can catch hold of the end of the shaft of the motor and turn it. Now what you do, you take any two colors and connect them together. If you can still turn the shaft freely, this is not one coil. These are not connected into a particular coil inside the motor. So we take any of the other two wires, connect those together, and the motor locks up. You can't actually turn it. Not unless you had a pair of grips on this and forced it, then you would be able to turn it. So the red and the blue are connected to one coil, and the green and the black are connected to the other coil, which is verified by the paperwork here. Red, blue, green, black. So that's how to determine how, if you don't have paperwork, how to connect them up to your driver. Because it's so difficult for me to have the camera down on the floor and have me crawling around on the floor, connecting up all the drivers and the Mach3 smooth stepper board, what I'm going to do is I'm going to show you in detail how to connect up the power supply that I have over here, the driver and the Mach3 board, and to have it working with Mach3. Now, prior to me switching the camera on, I loaded up Mach3 in this Windows 7 operating system. Now, you can use Mach3 on a computer that is running Windows, providing it was an original Windows 7 computer. Now, the reason for that is because Windows 7 computers, and 8 I believe, have a 32-bit operating system, and later models even had 64-bit operating systems, but they did have also a 32-bit leg. That means part of the system was 32-bit. Now, Mach3 operates on 32-bit. So If you try and put Mach3 into a genuine 64-bit only Windows 10 operating system, it won't work. You might even get a blue screen. So, you know, just be warned about that. So it must be an original, older computer with a 32-bit capability in it for Mach3 to work. Mach4 works solely on 64-bit. So any Windows 10 or now 11 will operate that. But Mach3 has been around for 20 years and is well proven, it's bomb proof, and so, you know, so are the computers like Hewlett and Packard. That are, you know, I always use Hewlett and Packard or Sony or Dell. They're all pretty bomb proof. So I'm going to show you first of all to check in Mach3 to turn on the outputs and just check to see whether the motor parameters are just general to be able to put a signal out to a NEMA 24 and the driver. So that's what we're going to do first. Check the output in Mach3. So what we need to do first is come up here to config. First of all, ports and pins, motor outputs, and make sure that they are enabled. X, Y, and Z. Now I'm using a smooth stepper board, so these are really so the smooth stepper can distinguish what you need or what the computer is commanding to be operated. Leave these at the moment. If you change these to a tick, you'll change the direction of the motor. Now everything in the smooth stepper is out on port 1, so the step and direction are both out on port 1, and the smooth stepper then will decide by these numbers what axis is to be moved. So these are now turned on, which is okay. So we can okay that. So the next thing we'll check now, go back into motor tuning. Now the 2000 steps, it's okay. Velocity 120, acceleration 4. These are fairly standard numbers, but we will change these numbers when we set the machine up for accuracy. We will need to change these numbers. This one, you change this, it'll operate faster or slower. But this is okay to test the driver and a NEMA 24 to see if it's operating correctly. We're not worried about this at all. Let's just check. Is X, Y is exactly the same, Z is the same, and this is all okay just to test this motor. So we know now we're going to get an output. Okay, so we'll just press reset, and the computer has given me a little bit of a noise to say, yeah, everything's okay. And I'm just going onto the keyboard now just to check the X direction, see if we can get a movement here. And we can. So let's set that back to 0. And now we will start wiring up the driver, the stepper motor, to the power supply and the smooth stepper. Mach3 board. Okay, so we have a power supply here with a positive and negative connection, and we're now going to connect into the driver. Now the power for the driver comes in on these two pins here, which is ground and voltage plus. I'll zoom you in a little bit closer so you can see what I'm doing. Okay, so we have a ground wire here which goes into this terminal. We'll screw that down. Incidentally, these terminals do pull out, so you can put the wires in the terminals outside of the machine if you wish. So that's the negative. Now this is the positive coming from the power supply. Now the next thing we're going to connect is the stepper motor. Now for that you will need your sheet from Stepperonline, and they will tell you here that it is black is A positive, green is A negative. So we'll do those two first. So black goes in A positive, which is in there. Green, the parrots are making a bit of a noise out there. So green is A negative. Red is B positive. And blue is B negative. That information is on the sheet supplied by Stepperonline. So the next lead is a 5-volt supply from the board, which is here. So the board actually supplies 5-volt to the driver. But you have to make a loop wire like this. Okay, so we put that one in first. Pulse 5-volt plus. Okay, and you just simply loop it over. So you just simply loop it over and put it into direction plus 5-volt supply. Okay, so it's just a loop over from one terminal to another. So you're supplying 5 volts to pulse, 5-volt plus, and direction, 5-volt plus. So now that wire goes to the 5-volt feed out of the Mach3 smooth stepper board here. So your computer with this particular smooth stepper board is supplying the 5-volt to the driver. It is really just a signal 5-volt. There's no great power required. So the next leads now is the step wire. Step for the, I'm just choosing the X. So that goes in here. So step on the X. We'll connect that one up. Direction X. So now we will take these step and direction wires and connect it into the driver. So this green step wire goes into here. and the direction wire comes into this terminal here, which is direction minus. So just to recap, we have a power source here, DC power source, positive and negative, coming into ground or negative and positive power feed in. We have A plus, A minus, B plus, B minus connected up for the stepper motor. We have a 5-volt supply coming from the Mach3 smooth stepper board, coming into pulse positive and looped over, supplying 5 volt into the direction plus 5 volt. And then we have the signal wires coming from the Mach3 board, which is the step and direction on X, and we come into pulse or step and direction minus. So they're both minuses. So the next thing to do is to connect the USB cable to the board, which we will do now live. You may or may not be able to see an LED light flashing here, and that is telling me that the computer sees it and everything's okay. So now I'm going to turn the power supply on. We've got a green LED light there saying, yep, everything's on and working. We've got a red LED there saying, yes, everything's working. We'll just turn this motor around a bit. I put a bit of tape on here to indicate. You can see that it's going one direction or another. And I'm going to take Mach3 out of reset and press the X, or the number 6 key actually, and we should see this go. One way and the other way. Okay, so I've broken this down now and wired it up for you outside of the machine so you can see exactly what's going on, and that is how it's going to be wired up in the machine. But there's going to be that many wires. Obviously it's going to be 4 times this. You know, it's going to be very confusing, so I thought put it on the bench and show you how it all connects up. Also in this video I showed you how to set the dip switches and how to define the coils if you don't have paperwork, and I hope it's helped you. And the next video, I think we're going to see some movement. So if you've enjoyed this video, please like and subscribe. If you would like to support the channel, you could also become a patron. The patron information is below this video in the video description area, and because it is the patrons that you know, are behind this channel that allows me to do all this. So thank you for watching, and I'd like to see you on the next video. Bye for now.